All right, so we have to solve the following questions, some calculation questions in the chemistry outline. This is stoichiometry. Said how many moles of potassium bromate are required to prepare 0.070 mole of bromine according to the reaction. Now, this is the reaction. If the reaction is balanced, firstly, whenever you are giving a question like this, is to ensure that the reaction is balanced. How many potassium do you have? There are 6, 5, and 1, making it 6. Here you have 6 potassium. How many bromine do you have? Here is 1, KBr, there are 6 here. Here also, you have 6, 3 times 2. How many nitrogen? Here you have 6 nitrogen. Here also you have 6 nitrogen, so now is balanced. How many hydrogen? You have 6 hydrogens here. Here also you have 6 hydrogen. How many oxygen? Here you have 3 plus 18, 21 oxygen. Here you also have 18 plus 3, 21 oxygen. So the reaction is balanced. Now, having ascertained that the reaction is balanced, the next thing you need to look at now is the stoichiometry. Now, how many moles of KBr react to give 3 moles of bromine? You agree with me that 1 mole, so you are going to write this out from the balanced equation. If you look at it, it's only 1 mole. There's nothing attached to this one, so it means 1 mole. You are going to say 1 mole KBrO3 will give 3 mole of BrO2. Therefore, 0.07 mole, 0.0700 mole BrO2 will be equals to X. This is a very simple question. X multiplied by this will be 3X is 1 times 0.0700. So divide both sides by 3. This cancel this. X would be equals to. So multiply that for me. And let us see what you are going to have. You have 0.070 divided by 3, which should give us 0.00233. All right, so that is option C, 0.0233 mole. So that's the answer to that question. It's a very simple question, right? Exactly. Let's see the next one. Calculate the mass of hydrogen formed when 25 grams of aluminium reacts with excess hydrochloric acid. Now, aluminium has an atomic mass of 27. So you are going to say 2 mole of aluminium gave 3 moles of hydrogen gas. So let's calculate the masses. 2 times the mass of aluminium here will be 2 times aluminium is 27, so we have 27 grams of aluminium will be 3 times hydrogen here is 1 times 2 is 2. So 3 times 2 grams of hydrogen. Now these are the mass, the theoretical masses of each of them that reacted. 2 times 27 will give us 54. So we can say 54 grams of aluminium reacted with 6 grams of hydrogen, or reacted to form 6 grams of hydrogen. They say 25 grams of aluminium. Calculate the mass of hydrogen formed when 25 grams of aluminium react. So if 54 grams of aluminium gave 6 grams of hydrogen, that means 25 grams of aluminium will be equals to X. All right, So we are going to cross multiply. It's going to give us 54x will be 6 times 25. So 54x, 6 times 25 will give us what? 150. Abina, 6 times 25 give us 150. So 150 divided by 54. So divide both sides by 54. Our x, 150 divided by 54 will give us 2.77 gram. So the correct answer to this question is 2.77 gram, which is approximately 2.8 gram. All right, and that is option D. The next, the limiting reagent in a chemical reaction is the one that is consumed completely. That is the limiting reagent. The limiting reagent in a chemical reaction is that one that is consumed completely during the course of the reaction. Now, that is the limiting reagent. If 5 grams of reactant were used for the following processes, the limiting reactants would be, what do you think is the limiting reactant? Now, I'm going to solve this question later. Let's see this question. How many grams of NH3 can be prepared from 77.3 grams of N2 and 14.2 grams of H2? So we have N2, let's write a balance equation. N2 plus H2 will give us NH3, the Haber process. Now let's balance the equation. You need 3 here. Here will be 2, and this equation is balanced. Abi? Yeah, it is balanced. All right. Now, how many grams of NH3 can be prepared from 77.3 grams of N2 and 14.2 grams of H2? This is a very technical one. A very, very technical one. But I'll come back to this one. You still need to know the limiting reagent and excess reagent for you to be able to solve this question. Now, how many grams of water are contained in 75.0 grams of 6.10% aqueous solution of potassium phosphate? Now, if you have a question like this, how many grams of water are contained in this? Now, when you have 6.10%, this one means 6.10 grams of potassium phosphate in 100 grams of water. Are you getting it? Now, they are not telling you that how many grams of water are contained in 75 grams of this. So it's going to be 6.10%, which is like 6.10, because you want to know for the amount of grams of water, divide by 100 times 75%, or times 75. This one will tell you the amount of potassium phosphate that is present in this 75 grams. So if you press the calculator, 6.10 divide by 100 times 75, that will give us 4.575 grams. So this is the mass of potassium phosphate in 75 grams of this. So total, you know, a solution consists of what? The potassium phosphate plus what? Water. So potassium phosphate plus water give us 75.0 grams. You've calculated that of potassium phosphate to be 4.575 plus water will be equals to 75.0. So to get for that of water, it will be what? 75.0 minus 4.575. So it's going to be 75.0 minus 4.575, which will give us 70.25. All right, approximately 70.3. If you want to go with any of the option here, you go with 70.4, which is option C. And I believe that is the end. I was actually considering my battery to solve this particular question. Now they say how many grams of NH3 can be prepared from 77.3 grams of N2 and 14.2 grams of H2. Now I want to know the limiting reagent first in this particular question given to you. Now, how do we know the limiting reagent? The one with the least amount of mole is the limiting reagent. So firstly, 37.3 grams of N2. Let us now calculate the mole of N2, which should be 77.3 divided by molar mass. Nitrogen is 14 times 2 is what? 28, which will give us 77.3 divided by 28 was 2.760 mole. So this is the amount of mole of N2. Now let us know the amount of mole of H2 to be 14.2 divided by hydrogen is how many? 2. That's the atomic mass of hydrogen. Alright? Hydrogen gas. Is it 2 or 1? It's 2. So 14.2 divided by 2 will give us how many? 14.2 divided by 2 will give us 7. Battery is running low. 7.1. Now you are not going to divide them by their number of mole. Hydrogen here is 3, nitrogen here is 1. So you are going to divide this by 3, which will give us 7.1 divided by 3, which will give us 2.366. It means that hydrogen will determine the amount that can be produced. So you have 14.2 grams of hydrogen. You are now going to say 3 times 2 here will give us 6 grams of hydrogen, gave us 2 times, this is 3 plus 14, 17. 2 times 17, which is 34. So 6 grams of hydrogen will give us 34 grams of ammonia. Therefore, 14.2 grams of hydrogen will be equals to X. To get our X, it will be equal to 14.2 times 34 divided by 6, which gave us approximately 80. 79.7, which is 80. So our X, I rushed this one, is 80.44, which if you want to choose any approximate answer here, it will be B. Alright, which is 79.7. So that's the answer to that question. We'll see in the next one. I'm going to solve this question again.